For my impatient viewers that don't like long videos, go away. Exit now, wait for the 5-minute version, which I'll release for you guys that just want to see, to the point, what part I changed to make it work. But for those that want to see troubleshooting, stick around. I have a Luxman LV103. This is my own personal amp. The phono preamp is completely screwed up on it. It's really loud on one channel, and we're going to troubleshoot this down to the component level. We're going to get started right now. This is my Luxman LV103. This is a 60 watt per channel hybrid amp with 2 buffer tubes in the front. These are being used as a tube buffer. These are the original tubes. This amplifier has never had anything done to it other than the switches have been cleaned and a couple capacitors were replaced in it years ago. This one here, it's had a couple mods done to it too. For example, the B speakers are wired to a relay to turn these into inputs, so that when the unit is turned off, the B speaker terminals are connected to the A speaker terminals. And the reason I did that years and years and years ago was because I used this in conjunction with my Macintosh 1600. So if I wanted to listen to the Mac, I'd just turn this one off, and whatever signal was playing out of the Mac would pass through the speaker B terminals and then out the speaker A. But if I wanted some power, if the Macintosh doesn't have the power that this one did, I could just turn the Mac off and turn this one on, and when the speaker relay energized, it would also disable the input so that the signal wouldn't feed back to the other unit. Other than that, it's pretty much stock. I'm having some trouble with it. It's been giving me some trouble for the last couple of years. The biggest problem with these is the switches. The switches go bad, and they've gone bad again. They've been cleaned before, but they need another good cleaning. Also, what has also gone bad on it is the phono preamp is not working. So I think today we'll clean up those switches, see if we can get the phono preamp working properly, and see if we can figure out why it's going into protection. Because it'll just be sitting there, and you'll just hear a thump, and it'll go into protection mode, and then it comes back on its own. So it's it's starting to have some issues. So it's time to service it. Now that I've taken it out of service, out of my studio, and I've put that Technics amp in place of this one, I can now do a service on this, because this is the amp that I've been using in my office to listen to music, and as part of my production setup, I've been using this as a monitor for many years. So now that it's out of service, I can give it a good service, and then someday I'll put it back into service again. So there's a look at the unit from the top. Looking straight down, you'll see that this has 2 separate transformers in it. Main power transformer and this small one. I think the small one on this one is actually just for the filament. I could be wrong, but I think it's just for the filament. And you'll see some of the reworking I did. This is the relay I put on at the back here. That's to switch between pass-through for the speakers, and so there's only one set of outputs, and that's the main. But this is the one. This is where I wired it up to switch the outputs, or when the set is switched off, which is controlled by the speaker B switch, by the way, on the front here. So when the power is off, the signal is passed through from the B speakers to the A. When the power is on, depending on what position the switch is in, if it's in the out position, the amp can be on, and I can be passing the signal through from the B right through to the A, and then when I push the B speaker button in, that'll actually put the power out the speakers from the amp itself, and the speaker A switch just turns the speaker A on and off. So I say it's been modified for my own specific use. It's not something that I'm going to sell anyway, so it's just an extra added feature when I use this in with my stereo system with my tube amp, which this may go back into my living room now that I'm not using it in my office. This may go back into my living room, which I do have a tube amp on, but that way I can have both. I can have my tube amp hooked up, and I can have this amp hooked up, so I can switch at will between the high power from the MOSFETs and the relatively low power from the vacuum tubes. And here are the MOSFET outputs. K405 and J115. Now these MOSFET transistors are no longer available, so if they get blown, there's going to be a problem because you can't replace them anymore. The first thing I want to do on this unit before doing anything else is I want to pull the bottom off and inspect for any cracked solder connections around any of the driver stage and everything, just to make sure that that's not what's causing this thing to go into protect, because when it goes into protect I hear a hum like it's throwing DC to the speakers and then it goes into protection mode. So I'm thinking there is a problem with the amp. Let's find out what it is and we'll deal with that. And then I got to deal with the preamp over here. Now you can see there's already been a couple capacitors changed on it that were replaced because they blew up. They were actually leaking onto the board. So a couple of caps were stuck on the back years ago just to get the preamp working. Preamp now has gone down again, so I got to deal with that as well. Of course, these amps were made at a time when things were serviceable. Get it like this. 2 screws. That's all it takes to open the bottom panel and have full access to the entire circuit board. Looks like this was modified at the factory at some point. They've actually added a separate circuit board connected to the power amp stage, so they may have changed the design from when it first was developed, and they've just added this daughter board. I have no idea what's under this, so we're going to take this daughter board out and just take a look at what's on here, because this has never been out of this unit. And we'll find it's just got some capacitors on it and diodes. And this is part of the protector. You see, it says right down here, protector PCB. So this is what's monitoring for any, I'm sure this is monitoring for any DC voltage or anything that's gone bad. A bad tube, for example, could drive this thing into a DC voltage, which could blow your speakers in an instant. So this is probably all part of that monitoring circuit. But it's just got a couple capacitors, 4 capacitors, 4 transistors, a couple diodes. So basically 2 caps and 2 transistors, 2 diodes, and what is it, 5 resistors, 3 diodes and 5 resistors per channel, 4 diodes. Anyway, that's that. First thing I want to do though is I want to inspect to see if there's any connection problems in any of these transistors, because it's old and solder connection problems do crop up in units of this vintage, like this one right down here. There's one that looks down here that looks like it could be kind of suspect. Of course my camera won't focus. But first things first, I'm going to go over the board and just give it a good inspection. Maybe it's time I got a new tip for the soldering iron. What do you guys think? I'm sure it's seen better days. It's quite old. So I'm just going to touch up these driver, I think these are the drivers, transistors here, either the thermal compensators, but I'm just going to touch these ones up right there, because they don't look like they're soldered all that well. This board actually does look to be in remarkable good shape. I don't see any obvious cracks like you'd see on some other brands that rhyme with Bony or Yamaha. I said those Yamaha with the bad connections on it, and I've seen lots of Sonys, but this one actually looks to be pretty good. But again, this was a high-end unit. You know, the Sonys and everything else was middle-of-the-road stuff. Luxman were up there with the Marantz and the Quads and the Lins and Leak and that stuff. So I'm probably going to get demonetized on this video from all the language from the kids next door playing hockey, dropping the F-bomb every other word.
The real question though,
So I'll just talk over them then. Very good. So I'm just going to go over some of these transistors in the driver stage. Even though they don't look bad, it can't hurt to reflow them, and then we'll pull the front off. I want to check the tube sockets, and I'm just doing a basic inspection now on this part of the amp, and then we'll get in, we'll clean the switches. I'm going to clean the whole front of it up too, because it's looking pretty bad. It's been a while since this thing's been cleaned up, and then we'll get into the heavy troubleshooting, which did take me a while. The raw files for this here was about 26 gigs on the camera by the time I got finished shooting all the shots to it. So we did a lot of shooting. There's going to be a fair bit cut down. I'm sure, as I say in the opening, there's still going to be people that are not happy with the length, but for those that are impatient, I'll release a short version of this for those people that want to see it done in like 5 minutes. We'll skip all this. We'll skip all this preventative stuff and just get right down to the problem. So I'm going to resolder the drivers. I don't see any cracked solder connections in here, at least not like I'm used to seeing on Sonys and Yamahas. We'll give each of the switches a shot of deoxit and give the switch a bit of a work here. So there's little holes in the back of these switches, which are nice because it makes getting cleaner into them really easy. Those little holes, by the way, I put in the last time I cleaned them, which was years ago. Because the switches, I couldn't get any cleaner into them that would get in and penetrate the switch. So yes, the neighbor's kids are that loud, and my door is closed, so you can imagine how loud they actually are talking. That's picking, the camera is picking them up. That there they go. They're taking off on their little electric scooters. 100% totally illegal, but riding their little electric scooters around with no helmets. Real smart guys. Okay, that should have those switches cleaned. Got to get to the ones on the top now, which are for the record output. That's these ones here, and again, like the other ones, I've got a little access hole in the top for spraying cleaner into. You're wondering why I didn't clean this one on the left here. That's because there's not a switch. That's just to release the other ones. That's the off button, which turns off all of the recording outputs. One thing I do want to access is the vacuum tubes. I want to inspect the actual tubes and the tube socket and everything. So I think I gotta pull the face off this to get at it if I'm not mistaken. I gotta pull the front bezel and the knobs and stuff off to get at the tubes. Never done it, so it's time that we check out the tube board and look for any connections on those, especially on the tube sockets, because it won't hurt to reseat them. That could be what's causing the thing to kick into protection mode. These tubes here have literally thousands upon thousands of hours of use on them, because they have never been changed in all the time I've had this thing. I don't know if this has to come off actually. Well, it removes the whole tube board from the back. According to the service manual, it just says remove the 3 screws, remove the volume knob obviously. The extrusion on the bottom actually has more screws that hold it in place that are in behind here, but it says just to pull it slightly and it should come apart. Oh, there we go. It's just stuck. Yeah, to take this one off there's more screws, which I don't need to get at because I don't really need to get at the volume controls. I will clean the glass here. Look at all the dust and dirt in here from just years of use. That's just from the heat in the tube compartment here. So here are the vacuum tubes in their tube holder and the little vacuum tube board. I should be able to remove this. I want to inspect the connections on this thing, so this should just come out. I think. I don't think there's anything holding it. There might be a clip on the bottom. There's a little clip on the bottom here that holds it in place. If I release that little clip, it should go through, slide out. It has that little clip right here. And then the tubes, which I don't want to break, obviously, because they will be expensive if I do break them. I don't want to break them, that's for sure. I don't want to damage the tubes. There we go. And then the tube board should slide straight out like this, and it'll lift up like that. Okay, now I can remove, or at least inspect, the connections on the tube sockets for any cracked or broken connections. I unplug this pink connector. Or I should say the pink wires with the white connector. If I unplug that, I should be able to slide the tubes forward, or the cover back. So much for brittle plastic. Here are the 2 tubes. No worse for wear. But I do want to inspect these connections on these sockets. Let's remove the tubes for safekeeping. I'm just going to resolder these pins on the tube sockets, because a couple of them just don't look, under the magnifying glass, they just don't look good. Like the solder doesn't want to stick to it properly. So I'm just going to reheat. And reflow these pins. See, that one just does not look good. These tube sockets have been really difficult to solder. So I need to get a close-up look. See what I'm seeing here before I even put the heat on. You see the cracks right around here? So this is what I was seeing on all of them before putting heat to them. You can see it. I wonder if I bet you it'll break if I try to even move it. You see? See, these weren't soldered down very well, I don't think. That's one before I put heat on it, because watch what happens. The solder just does not want to stick at all to these pins. I got to get them really, really hot to get the solder to flow. This may have been part of my problem with the trouble I've been having with this thing intermittently for the last couple of years. As I say, it's an intermittent problem. It would come and go. So even when I get this back together, I won't know for a while whether I've actually solved the problem, because this problem with it going into protection mode would be something that would pop up. You know, it would pop up once in a blue moon, and then I would just shut it off and let it sit for a bit and turn it back on, and it was fine. And it would be fine for weeks. Like, you know, it would do this maybe once every 3 or 4 weeks. It would get into this state where it just wanted to go into protection mode and would not give me any sound. So this may be the problem with that right here on these tube sockets, where you get to a crack and it causes a voltage fluctuation that's detected by the protection circuit, which just shut everything down. That's what I kind of think is, from the look of these connections, to say both sockets had flaky connections, and when I went to resolder them, the solder just did not want to take at all to the actual pin. It would flow fine on the circuit board, but on the actual pin itself, it did not want to adhere at all. I had to get them really hot to get the solder to flow. So that may have been what was causing this intermittent problem on this amp. Going back and say, this has been doing it now on and off for the past couple years. I just hadn't got around to taking it apart and fixing it, because I've been using this as my amp in my studio. So until I put another one in to replace it, which the Techniques is going to stay in my studio now, and this will now be put somewhere else in one of my other systems once I get it all overhauled. Just wanted you guys to see the tubes. You notice that they're American made, USA tubes. 6CG7 or 6FQ7 are the numbers. I'm just cleaning the tubes up a bit because, of course, they've been sitting for so many years, they're kind of dirty. So we're just going to clean the tubes up a bit because, you know, they're kind of dusty. Just going to use a bit of isopropyl alcohol on a clean rag. We'll wipe the tubes down, clean them up, make them look like new. Do the old eBay trick. Clean everything up so it looks like new and then sell it as a new part. Is that what the guys on eBay do? Maybe not all of them, but a lot of them do. And by a lot, I mean the majority. You go on there to buy a part, and the seller will always assure you, oh, this is a new old stock part. 9 times out of 10, it's not. 9 times out of 10, it's one that they've pulled from something that's gone in to be recycled. We'll put this on the top here just to protect the tubes like they had before. Not that it's going to be bashed around or anything, but might as well put everything back the way it was. Snap it in place. Plug the tube socket back in. See, now they look like they're new. As you can probably imagine, this is one of my favorite amplifiers that I've got here. This is the most expensive piece of equipment that I think I've ever bought. Because when I worked in the business, of course, I was able to buy stuff direct from the manufacturer. I was able to buy all my stuff wholesale. Except for, we were not a Luxman dealer, so I could not buy Luxman. So I actually had to go to a retail store and actually buy this thing. And it cost me a bloody fortune. All my friends told me I was on drugs. And when I tell you what I paid for this amplifier, I bought this amplifier in 1980. I think it was 84. The reason I say that is because that was the year that I started working at the repair shop that I was at for 20 years. Which is, you know, now out of business. But they were there for 47 years. I was there for almost 20 of those years. And we were a Sony and a Techniques dealer. Techniques, however you want to pronounce it. But so for me to go into another shop and buy something at retail, I was told I was an idiot. But I tell you that I wanted the LV105, but I couldn't afford the LV105 because it was like $2,500. And this one here was like $2,100. And for the extra, I think it was 20 or 30 watts per channel. I wish I'd gone with the 105, to tell you the truth now. But at the time when I was spending that kind of money, and it was a lot of money, that extra couple watts, to me, I couldn't justify like $400 or $500 difference in the price for an extra couple, an extra 20 watts or so. I think this one was rated at 60, although the service manual says 50. But when it was sold to me, the manual said 60 per channel, and the LV105 was rated at 80. Service manual would probably show it as 50 and 75, but beside the point. For the difference in the power, the difference in the price, I went with this one, and it served me well over the years, other than the switches here, which have been ongoing issues on these units. Anyway, I've cleaned up the front panel, cleaned up the tubes, resoldered the tube sockets. Let's put the front panel back on now. This thing looks like new. Look at how clean that thing is. It just cleans up really nice. And it just snaps in place. Somehow it snaps in place. Like that, and then there's 3 screws that hold the top in, and I took 3 out from the bottom, so I'm going to put those back in, and then we'll hook this thing up and see if it will produce any sound. I guess I better clean that knob up. That looks kind of gross, doesn't it, with all the dirt around it. We'll just polish that up, make it look like it's brand new. Okay, you know, like this, first thing we should probably do is turn on the preheating. That will preheat the tubes. We're going to let the tubes preheat for a couple minutes before actually powering it up, because tubes themselves don't like to be shocked. They like to warm up and be at operating temperature when the voltage is applied. So what this has is it has a preheat circuit. Actually, even if I turn it on cold, you won't get sound for about I don't know, about maybe a minute, because it will preheat the tubes for a while before it actually turns on the speakers. But with the preheating turned on, it warms the cathodes up to not to their operating temperature, but it puts about half the volts. It puts about 3 volts across the filaments instead of 6. So that keeps the tubes warm, so that when you turn on the power, it will start playing a little quicker. So I've got the input source on CD on this one. So let's turn it on. and see whether we get any sound. Tubes are now fully warming up. I meant to clean that control. I never use the tone controls, right? So even playing heavy metal, it sounds pretty good. Are my controls? I think my switches are good now. Except for the phono preamp is noisy. Getting a bit of leakage there somewhere. That switch is dirty. That switch is back here. How clean, well, I don't know how it sounds on the microphone because I'm probably overloading the crap out of the camera, but even though these crappy little speakers I got here are my test speakers, this sounds incredible. The sound quality off this amplifier is probably one of the best sounding amps that I've ever heard, and that's why I like this amplifier so much. And the amp in my studio that replaced this was that SUV9, and you know, as good as it sounds, I think this one sounds better. Just gonna blow the dust out of it. Yes, I turned it off to do this, by the way. Now I need to deal with the preamp problem, as the phono preamp is not working correctly. So the first thing I'm going to do is I'm going to take off the shield cover. See, this one's had a couple caps replaced on it because they actually were leaking. It looks like these ones are bulging as well. This is a new one. I believe these operate at pretty high voltage on them. They're high voltage caps too. They're 160 volt caps. I wouldn't have put big ones in like that unless this thing's operating at high voltages. So let's just see what voltage they're operating at. Okay, what are we on here? 60 volts. Yeah, so we're running at 60. That's why I went with high voltage caps. Well, I kind of overkill because I didn't have any 160s. I went like 450 volt, but this one looks like it's bulging. If you look at the top of this one, it's popping up, so maybe I'll have to replace this one again. Try and put this in from the top. And you can see that one there, the top is lifting up on this one. Connections on this transistor looks like it's bad. Looks like there's a bunch of connections on this board. The other board looked good, but look at these ones down here. Removal of 3 screws, and that cover lifts off. This is the shield for the inputs and the preamp. We look down at these connections here. I bet you if I move these transistors on the other side, we'll see them wiggling through the board here. It's cracked all the way through. Where the heck are they? Oh, there they are. They're regulators of some type, I think. But I think if I move those, you will see them. You will see them wiggle through here. See that? The next one over is this one here. Yeah, those connections are bad. And that's in a regulator on the tone and preamp board. So we're going to fix these. There's a whole bunch of them that are bad. These ones here, look at the cracks. I'm going to have to resolder this whole board. Then we'll get these caps mounted somewhere. Put them in here somewhere. They're just the power supply. Positive one, here's the positive is marked plus, and that goes right to this cap there. The positive side, there's the negative side of it there. And then the other side of the plus comes down and it goes to the positive side of this cap as well. Looks like. One, the positive is on the left, and the other one, the positive, is on the right. But you can see the original ones came out because they were leaking. They were leaking electrolytic onto the board. You can see right here, if you look at the board here, you'll see where it has actually caused a bit of corrosion on these jumper wires. They're not open, but it's left a residue behind for sure on these jumpers. And that's what happens when electrolytic leaks in the capacitors. You can see it right down here, green. I don't think it's causing a short or anything, but it certainly is, might be causing some leakage between those ones. That's why I'm going to scrape it out. The electrolytic that leaks out of them is corrosive and conductive, so it causes leakage. So you want to make sure you scrape all this stuff out whenever there's been a cap that's gone leaky. Okay, time to fix these connections on this board. We'll redo the regulators on this board and everything else. It looks like it's bad, and hopefully that's going to fix and clean the switch here, because that's the moving magnet, moving coil switch. We'll clean that switch up, but hopefully that's going to solve the problems with this little amp as far as the phono preamp goes. Another search of the parts tray finds a couple of 100 volt, 100 microfarad, 105 degree capacitors. These will work just fine. The original ones were 47 microfarad at 100 volts. So going up to double the size, these are just power supply filters, not going to be a problem. So let's get these ones mounted, and these ones should fit on the board where the original ones were. So let's get these ones mounted. The easiest way to get at this, to do this type of work, is to remove the input board, and that requires removing a couple screws, one that's in the side here and the plugs on the back, and then the board should be able to lift out so that I can actually change the parts on this thing, because that big heatsink is in the way. Now I gotta be careful with this. This is the flexible cable that controls the inputs for, oh, I've got to remove this ground wire, for the phono. So you don't want to bend that too sharp, otherwise it will get a kink in it and then it won't work. So it might be better to actually cut this tie strap, but I think I can probably manage without it. I only have to get the board out enough to get the parts in. So now that the board is out, I can fit the parts in the board. I don't really need to take it out any further than that. Just enough to fit the parts in so that I can tack them through from the other side. Okay, now I can tip it back down and solder the parts in, and then I can put the board back in. So that's what you want to do if you want to change these parts. Do take the board out, because it will be a lot easier than to try and get those parts in place with that heatsink in the way. Trace here is kind of a bit damaged, so I'm just going to scrape off a bit of the solder mask here, and that way I can get a good, bend that pin over and get a good connection. Now we can mount the board back in place. Okay, let's give this thing power again. And I didn't have the preheating on that time, so it's going to take a bit to heat up here. There we go. Okay, and CD. Yeah, what happens if I put on phono? let's clean that control. Let's clean that control up first. I'm getting some crosstalk from the other inputs, but again, there's no load on the phono cartridge input right now. So let's just clean up that control, and then I'll hook up a turntable and see if it actually does anything. I've got my turntable connected now. We still have a bit of a problem. One side is much louder than the other. If we listen to this, okay, I got it playing. That's the left channel. We'll go to the right channel. Anyway, we got one channel much louder than the other that I have to investigate. So let's continue. So here's our preamp circuit. There's a, I think it's an FET in here. There's a couple of them, but this is the left channel and this is the right channel. And this side is overly sensitive. That's why it's picking up so much crosstalk from the CD input, because the gain is so high on this side. Here's the left channel, right channel, so still way too much gain. And you can hear leakage from one channel, but not the other. You don't hear leakage on the left channel, just on the right. Because the right has got so much ready gain on it. I may have to actually even look at the manual for this thing to figure this one out. One thing I'll notice, there are power lights for the different circuits. This is the phono preamp circuit. There's also power lights up here in the various circuits of the power amplifier. There's 4 of them. You can see the 4 LEDs glowing. Which is kind of neat. I got a schematic for this thing, for the preamp. So let's take a look at that. So as can be seen, this is our phono input, left and right, the equalizer amplifier. This is, I believe, our switch here. This is for moving a coil or moving magnet. And in one position it just changes the gain, basically. I think what it basically does is it takes this part of this transistor out. This is a dual transistor. As you can see, it's a dual FET. There's 2 of them in the unit, and then it goes into IC2105. I think my problem's got to be somewhere in this area here. Something is driving this thing into so much gain on one channel. So I think what I have to do is I have to just kind of compare voltages between the 2 of them. These are the transistors, the dual FETs I'm talking about. So that one's for the left channel and that one's for the right channel. And they also have a voltage regulator here. This is a voltage stabilizer transistor here. They've got their little lights that are on to indicate it's got power. And then the IC, the preamp IC, is this one right over here, which is hiding in behind this. This is the preamp IC here. IIQ, they call it Q2105, which is right here. Or IC2105? They call it Q2105. What the heck? It's the only IC in there. It's this one right here. IC2105 and MJM2043. And that's it there, 2043. So that is the IC, the preamp IC. So what we can do is we can actually put the scope on here and just take a look at what's going in and see if the signal's hot getting in here. I'm sure the signal is hot getting into here. Our problem is further back, but we can actually look at both the inputs because we've got them right here. We've got them right here, right? The different pins, pin 2 and 3 and pin 5 and 6. So let's take a look at the input to the IC. So I've got my my MP3 player turned down. It has a volume control on it, so I can turn it right down. I've got it plugged into the phono input. You can hear the difference in the levels. There's the left channel, and if I roll the balance, there's the difference. I'm just going to do some voltage comparisons. We're going to measure it at the FET here, both the FETs. I'm going to measure the voltage on all the 6 because it's basically a dual FET. So I'm going to measure the voltages and compare the 2 of them here. So because they're both the same, we should get similar voltages. 0.1, 0, and 16, 16, 0, and 0.1. Right? Okay, that's one. Let's go to the other one. The other one's down here. 0, 0. Okay, 15.8. Should have the same down here. 15.8, 0, and 0.1. So the voltages are the same for both of them. That's right here on these two dual FETs. So why are we so much louder on one side than the other? I have a sneaking suspicion because one of them's got attenuation and the other one doesn't. Let's just see here. Let's just put the scope. We'll look at the output. There is a feedback from, looks like pin 1. No. Yes. There is a feedback loop from pin 1 and pin 7 of the IC that goes back to that FET as well. So I'm going to look at the two outputs from the IC. This is going to be pin 1 is the first one, which is the, I think that's the left channel. So this is pin number 1. No, wait a minute, sorry. Pin 1 is the right channel. Pin 7. I think, yeah, pin 7. This is pin number 7. So this is the output. Buddy. So that's the left channel output. Now if we look at pin number 1, you can see how much higher the signal level is. Much higher. Now it feeds back. If we look at the feedback from here, you'll see that there's a feedback loop here. There's a I think it's a 3.3 mega ohm resistor that goes into the gate of this FET to control the gain. So if that resistor were to change value and go open, we'd have no feedback to control the amount of gain that's applied to the IC. So we're going to check that resistor. Here it is here. It's actually a 3.9 meg resistor. There's one right there. Orange, white, green. And there's the other one there. I'm curious, has that resistor gone open? Because it's a 3.9 meg resistor, we're not measuring that in the circuit. I have to remove it to measure it. So we're going to test that one and see whether that one has changed in value. I see the problem. Do you guys see it? It's caused by capacitor juice. Right in here, there is a Zener diode. Will this focus? So the voltage stabilizer for the circuitry here. I think it's this one here, D1104. Anyway, take a look. D1104 has one lead that's been eaten away by capacitor juice that spewed out of this cap a while back when the original cap blew and it got shit on the board. It's eaten away at that one. Has this one popped as well? I wonder if this... Oh, both of them are gone. So both these Zeners are going to have to be replaced. There is where my problem is. Voltage regulation. Now, I don't have a Zener, I'm sure, of that size, so I'm going to have to get a couple Zeners. But I think that will fix this one. Oh, and incidentally, that resistor measured fine when I got it out of the board. But D1104 and D1103 look like they're both terminal. So those two Zener diodes that are blown are both 20 volt. They are in the positive and negative voltage regulation circuit for the IC over here. I got to replace them because they're shot, obviously. I don't know that that is going to solve the problem at this point, because the IC appears to be operating properly on the left channel, but the right channel is overly loud. And, well, they're common. So you would think that if that was causing the problem, it would affect both channels equally. But that certainly is part of the problem, is that zener, or those two zeners that are open. The 3.9 meg resistors, by the way, here, they're in the negative feedback circuit for the phono preamp. That's what they are. That's what they do. That's their purpose, is the negative feedback. But there is another feedback loop which goes through a couple capacitors and makes its way back, that feeds back into the FETs here, the dual FETs. I've just been going through this circuitry, this feedback circuitry here, looking to see if I can spot anything. I'm looking at C2118 and C2117. These are both in the feedback loop. And I'm just measuring resistance. So if I look at 2118, or is it 17? Anyway, 240K. And this one here is 81K. Definitely have a difference in the resistance across that junction, or across this capacitor. Now it can't go this way because there's a 3.9 meg resistor here. So a 22K resistor between ground and this one, but you know, we got a loop, we got ground here, 100 ohms, 33 ohm, 4.7, 56K. Well, it's a 1 microfarad, it's a bipolar cap, but it's a 1 at 50. And I'm getting like 0.03. Yeah, it looks a little low. It's supposed to be 1 microfarad. Wonder how the ESR looks on this. That could certainly do it, because it is in the feedback circuit that affects the gain. It's open. Completely open. We're making progress, but I'm going to keep you guys in suspense. Join us for part 2 when we finish this amp off, because we're out of time for this one. Thanks for watching. We'll catch you in the next one real soon.